Mean, median, and mode show up constantly on the SAT in both calculator and no calculator contexts. The arithmetic is usually light, but the wording can hide whether you need an average, a middle, or a frequency champion. We will practice sorting, averaging, recovering missing values, and understanding how outliers tug the mean while the median stays steady. By the end, you will know which measure the SAT wants when data is skewed or polluted by extreme values. If a problem mentions a frequency table, remember that mode is visible instantly from the tallest bar or largest count. The mean is the average. Add every value and divide by how many values you have. The median is the middle after you sort. With an even count, average the two middle numbers. The mode is the most frequent value. A set can have more than one mode or no mode at all. On time to sections, label what you are solving for before you touch arithmetic. Mean questions love to sneak in an extra data point, a duplicate value, or a sneaky change in sample size that breaks your denominator if you're not watching. Easy example, the data set 2, 3, 5, 7, 8. It is already sorted, which helps. The mean is the sum 25 divided by 5, which equals 5. The median is the middle entry, which is 5. The mode is absent here because every value appears once. Medium style, find a missing value when the mean is given. Use sum equals mean times the count. Suppose 5 numbers have a mean of 10. Their sum must be 50. If 4 of the numbers are 6, 8, 12, and 14, their partial sum is 40. The missing value is 50 minus 40, which equals 10. Harder conceptual question, what happens when you add an extreme outlier? The mean moves a lot. Start with 2, 3, 5, 7, 8 again. The mean is 5 and the median is 5. Add 100 as a sixth value. The mean jumps because 100 pulls the average upward. The median becomes the average of 5 and 7, which is 6. It moved only a little compared to the mean. That is why the median is called resistant to outliers. It tracks the middle position, not the gravitational pull of distant extremes, which is exactly why statisticians prefer it for skewed real-world data, like income. Common mistake, grabbing the middle value before sorting. The median only works on an ordered list. If you see 8, 2, 9, 1, sort first. Otherwise, your so-called middle is just a random interior pick. Another slip is confusing mean with median when duplicates exist. Mode cares about frequency, not position. Set pro tip, when a data set is skewed or has extreme values, prefer the median as a typical center. The mean is sensitive, the median is robust. If the question asks for a better summary of typical salary, say median. If you must predict how an added point changes measures, think direction and magnitude. A huge high score raises the mean sharply, while the median might barely move, especially when the sample size is large. Recap. First, mean equals sum divided by count, and it shifts strongly when outliers appear. Second, median needs sorting first, and for even counts you average the two middle values, which is an easy place to forget the divide by 2 step when you are rushing. Third, mode is most frequent, and missing value mean problems use sum equals mean times n, so always lock the count before you solve for the unknown. Practice more on NovaMaths.